Hi everyone, good evening, and in this video we are going to discuss about two most important medicines that are used in the field of health and medication. And in the first segment of this video we are going to discuss about the DNA transistor, and in the second segment of this video we are going to discuss about the X-ray medicine. So firstly, here we have a sketch diagram of a DNA transistor here. And firstly, we are going to define what exactly is DNA transistor. So DNA transistor is a big word there, made up of two different words, DNA and the transistor. So DNA refers to the blueprint of life, as we know, and transistor is a technical word, and it refers to a semiconductor component that controls the flow of electric current. So generally, DNA transistor is a machine that controls the DNA symbol from flowing through the nanopore of a DNA transistor. So how does this DNA transistor function? So firstly, when the scientist or a doctor wants to sequence a DNA of a person, then he or she needs to put a sample of a DNA here, and then they will switch on the circuit, and the electric current will flow through this circuit here, and this part of the electrode here is a negative terminal, and it is connecting to where the DNA sample is residing. So as the electric charge is flowing through this circuit, and since the electron is movable, and positive protons here attract these electrons to flow through the pore here, which is called the nanopore. So as it attracts the electrons, the electron flows together with the DNA sample, since it is with the DNA sample. So it flows through this one, this pore here, and as it passes through this nanopore, it is being sequenced, and the result are shown on the monitor, and that's where doctors analyze the DNA of a person or an animal. So that's how doctors use this DNA transistor and how it functions. And secondly, let's look about this X-ray medicine. As the same goes, X-ray medicine is also a big word, made of the word X-ray and the medicine. So here, X-ray is simply talking about the electromagnetic spectrum in the EMF, and the scientists or the engineers who first discovered this and designed this X-ray machine might have found a potential of this X-ray in the field of health and medication. So that's why they came to introduce this X-ray machine to the hospitals and in some fields as well. So here we have a part of an X-ray machine here in this glass tube. In this glass tube here we have a anode, and this is the negative terminal of this X-ray machine, and this one is a cathode, and it is the positive terminal of this X-ray machine. So when the electric charge is applied to this X-ray machine, the charge or current flows through this way, the cathode, and then it flows out through here, and this arrow represents the fast flowing electron. So when it hits this anode, this tungsten metal here, this is made of tungsten, and this tungsten is placed in a diagonal way to reflect this beam of electron and towards the window. So as it goes towards the window, it penetrates through the targeted area, which is the human body. So when the X-ray penetrates through the body, it it creates an image of black and white on the monitor, and the type of image, either black or white, appears depends on the type of tissue and the way how these tissues absorb the the X-ray beam. So especially the bones appear white because they absorb much of the X-ray beam. So if a bone is fractured, then the fractured part will be appearing black on the white background. So that will be shown up in the monitor, and that's how doctors use this X-ray machine to analyze and predict what kind of medication would be given to the patients. So that's the small explanation about the X-ray machine and the DNA transistor.